Good afternoon from the space coast of Florida, where 4 astronauts are about to suit up for NASA's boldest test flight in a generation.
And this view on your screen, that is Earth in the center of your screen from the Orion spacecraft. Again, a camera mounted aboard the spacecraft's solar array wing, looking back at all of us.
Our goal is to pursue the secrets of the universe, to change the world in air and space.
Have a ton of people gathering around the world to watch this history-making moment.
A rocket exploded on a launch pad at Cape Canaveral Space Force Station on May 28, 2026. The fireball was visible as far north as South Carolina. No one was hurt, but the vehicle that blew up was Blue Origin's New Glenn, one of only 2 rockets NASA is depending on to land American astronauts on the moon. And right now, Blue Origin has no backup launch facility. We are in a moon race that is moving fast, running on thin margins, and just absorbed a hit that a tight timeline cannot easily afford. The explosion isn't the story. Let's be precise about what happened, because the explosion itself is the easier part to understand. On May 28, 2026, Blue Origin conducted a static hot fire test of New Glenn at Launch Complex 36 at Cape Canaveral Space Force Station. Seconds after the 7 BE-4 engines ignited, the vehicle exploded. The rocket was destroyed, and the launch pad took significant damage. The FAA opened an investigation immediately. All personnel had been evacuated before the test, and no casualties were reported. The rocket will be rebuilt. The pad will be repaired. Blue Origin will return to the launch pad. That part is straightforward. Here is the part that matters more. Artemis is not a single vehicle that NASA controls end-to-end. It is an interconnected architecture of components built by separate commercial partners, each on its own schedule, each critical to the whole. When one piece of that system absorbs a serious hit, every other piece feels the pressure. Blue Origin controls 2 of the most mission-critical elements in NASA's current lunar plan. Both are now grounded with no confirmed return timeline. That is the real story behind the explosion. When most of us think about Starship, we focus on the launches, the test flights, the booster catches, the sheer scale of the vehicle. That is the part that makes the highlights. The real bottleneck sits somewhere else entirely. Starship's role in Artemis is to carry astronauts from orbit down to the lunar surface, but it does not arrive at orbit fully fueled. It gets there with crew aboard and then waits. Separate tanker starships have to launch, find it in orbit, dock, and transfer massive quantities of cryogenic liquid methane and liquid oxygen before the mission can continue toward the moon. NASA's HLS architecture requires approximately 10 tanker launches of propellant to a depot in orbit to refuel a Starship sufficiently to reach the lunar surface. SpaceX has confirmed the in-space propellant transfer flight test is targeted for 2026, with exact timing driven by how the new Starship V3 architecture flight tests progress. That test has not yet been completed. Here is where things get genuinely difficult. Cryogenic propellants do not sit patiently in a tank. They want to boil. Liquid oxygen and liquid methane are stored at temperatures hundreds of degrees below zero, and even with insulation, they warm and evaporate continuously. Every hour, a fueled Starship waits in orbit for its tanker. Propellant is disappearing. The transfer has to happen fast, precisely, and in the weightlessness of orbit where fluids behave in ways that ground-based engineering cannot fully replicate. No organization has demonstrated this operationally at this scale. A SpaceX internal document from late 2025 reportedly targeted June 2026 for a first orbital refueling demonstration, placing a crewed lunar landing no earlier than late 2028 on SpaceX's internal schedule, well past NASA's publicly stated targets. That gap between the 2 schedules is one of the most significant pressure points in the Artemis architecture right now. And while we work through it, China's crewed lunar program is advancing steadily, with the Long March 10 rocket, the Mengzhou crewed spacecraft, and the Lanyu lunar lander all progressing through major hardware tests and a confirmed crewed landing target of before 2030. The race is not just against the physics of orbital refueling, it is against a clock set by a competitor that is not waiting for us. We can solve every rocket problem on this list and still not land anyone on the moon if we cannot solve the suit. On April 20th, 2026, NASA's Office of Inspector General published an audit of the Next Generation Spacesuit program. The XEVAS contracts, worth up to $3.1 billion and now held solely by Axiom Space after Collins Aerospace was removed in 2024 for failing to meet schedule, were originally intended to demonstrate lunar and microgravity suits in 2025 and 2026, respectively. Both suits are at least 18 months behind schedule. Axiom is targeting spacesuit demonstration readiness in late 2027. If testing follows historical averages, the OIG concluded those demonstrations would not occur until 2031. Let us be direct about what that means for the mission. Without a functioning suit, no astronaut steps outside onto the moon. Apollo suits were designed for hours of surface activity. The suit we need for Moonbase has to handle days of continuous use, potentially weeks, in an environment coated in dust that Apollo astronauts described as the most abrasive and clinging material they had ever encountered. That dust works into seals, degrades joints, and compromises life support over time. Building a suit that survives extended lunar operations is a problem NASA has been trying to solve for nearly 2 decades without success. If the suit timeline slides to 2031, crewed surface operations slide with it. This is the constraint that almost never leads the headlines and carries as much mission risk as anything happening on any launch pad. NASA's Moonbase changes the conversation to understand why all of this matters as much as it does. We need to zoom out and look at what these systems are actually in service of. NASA's Moonbase initiative, detailed publicly on May 26, 2026, is a phased plan to build a permanent operational outpost near the lunar South Pole, with Moonbase 1 targeting launch no earlier than fall 2026, using Blue Origin's Blue Moon Mark 1 Endurance lander to deliver scientific instruments to the Shackleton connecting ridge. The South Pole is the target because of 2 resources that could change the economics of everything beyond Earth. Certain ridgelines near the pole receive near-continuous sunlight, making consistent power generation viable, and in permanently shadowed craters a short distance away, water ice has been sitting undisturbed for billions of years. That ice can become drinking water, breathable oxygen, and rocket propellant. We are talking about the raw ingredients for life support and fuel, accessible to whoever builds the infrastructure to extract them first. NASA has awarded Astrolab $219 million and Lunar Outpost $220 million to build crewed and autonomous rovers for surface operations, with Blue Origin receiving $188 million, plus an option worth $280.4 million to deliver them to the South Pole region by 2028. Every one of those missions now depends on Blue Origin's investigation resolving on a timeline the program can absorb. Here is what we need to understand about how Artemis actually works, because this is the part most coverage misses. The program does not succeed because one system performs. It succeeds when every critical system matures at approximately the same time. We need SLS and Orion to carry the crew. We need Starship or Blue Moon to carry them to the surface. We need the suit to let them step outside. We need rovers to extend their operational range across terrain. We need cargo landers to keep the base continuously supplied. We need power systems to run everything through 2-week lunar nights. Every single one of those systems has its own contractor, its own timeline, and its own technical risk profile. One delay anywhere creates pressure everywhere else. Right now, we are looking at multiple delays simultaneously. Blue Origin is grounded with no backup facility. The spacesuit program is at least 18 months behind, and potentially years further, if historical testing patterns hold. Starship's in-space propellant transfer demonstration is targeted, but has not yet occurred. and the proposed FY 2026 budget includes a 25% cut to NASA's overall funding, the largest proposed reduction in the agency's modern history. Each of those challenges is manageable in isolation. Together, they are compressing the margin that a program this complex needs to hold its schedule. The commercial partnership model that Artemis is built on brings real advantages in innovation and cost distribution. It also means that when a partner absorbs a serious setback, NASA absorbs the impact alongside them. The explosion on May 28, 2026, made that dynamic impossible to ignore. While we are working through these challenges, China's program is not waiting. China is aiming to land astronauts on the Moon before 2030, with research and construction for the lunar landing phase progressing steadily. The Lanyu lander has completed landing and liftoff verification tests. The Mengzhou crew capsule is scheduled for its first uncrewed flight in 2026, the Lanyu lander in 2027, with a joint crewed test mission planned for 2028 or 2029. China's program is state-directed and centrally funded. It does not depend on commercial partners holding their timelines. It does not face budget cycles driven by changing administrations. It has a single stated goal and has been building toward it without interruption. The south pole of the Moon has limited real estate. The ridgelines combining near-continuous sunlight with proximity to ice-bearing craters cover a small and specific geographic area. Whoever builds operational infrastructure at those locations first sets the standards and shapes the governance frameworks that every program arriving afterward must work within. Every month that passes with American systems grounded, delayed, or underfunded is a month during which China continues advancing. The Blue Origin explosion will be investigated, the pad will be repaired, and the program will continue. That is the honest assessment of the Blue Origin explosion that occurred on May 28, 2026. What we should carry out of this video is the bigger picture. We are in a moon race with real stakes and a genuine competitor, built on a commercial architecture that is more interdependent than any previous American space program. The spacesuit is behind. The refueling system is unproven at scale. Blue Origin has no backup facility. The budget is under serious pressure, and China has a 2030 target it is actively building toward. The outcome is still genuinely open. The decisions being made right now about which missions to protect, which timelines to hold, and which risks to accept will determine whether we are watching an American crew step onto the lunar South Pole before the end of this decade or watching someone else do it first.